Elzbieta, would you like to go, ma'am? Oh, you're muted. I'm sorry. Let me here. I'm going to ask you to unmute. Okay, and I'll allow.
Hello. Yes, hello. Thank you very much, Mike. That was really great presentation and a very great machine you built. Well done. I just have one question. How fast was the disk rotating in your machine?
Well, first of all, I'll say it wasn't a disk, but
yeah, that wheel.
It was maximum of about 200 revs.
Okay, maximum, but you didn't have a way of like measuring or?
No.
Because it's interesting if you were to spin it faster or rotate it faster, whether it would go faster.
It would go faster, but I am at the limits of what I can do in terms of finance and development. I mean, the machine you see was built on the table it was demonstrated on, which is my dining room table. It's something, I'm a retired engineer, so I no longer have a workshop. So anything I've done, I've built literally on the dining room table. I could make it go faster. I could go on and on and on. But once I established the principle of the function, which is the main thing, I knew it is now out of my hands, or should be taken out of my hands, because it needs a great deal of resources and a great deal of thinking behind it to develop it. I made an analogy before in saying that it was like the jet engine. Frank Whittle, the originator of the jet engine, only took his invention to a couple of pounds of thrust, but he proved the principle. And then he took the rest of the world to take hold of that principle and develop it. Working out, I'm not a mathematician. I could work out the revs from various other things and work out what speed it'll go at, what revs it goes at, but that's not what I'm about. I was about creating a machine that worked and the principle of that working. And then that principle needs to be passed over to the world and everybody else because it needs the collective thinking of lots and lots of people. There's innumerable ways I can think to make it go faster now. There's any number of ways. I mean, if somebody takes it up, I'm very happy to keep involved in the machine and tell them how they can do it and how they can make it go faster. And once they understand how it actually works, they can then think of developing or engineering it up to provide a lot more thrust and power. But that's the main thing, knowing how it works. With an awful lot of things, people say, oh, that's strange, that's an unusual thing. And oh, but that's no good. And unless you actually take the strange and unusual thing and you actually find out what's making it tick, you can't improve it or develop it. Now, I know what makes it tick now. So I can pass that knowledge on to people with lots of money and lots of brain power, lots of engineering brain power, to take that little engine that I've created and turn it into something wonderful. I mean, that particular engine will provide ship's power. It will provide power without propellers, without the fouling of propellers, without a rudder even, which just on a simplistic viewpoint will save ship owners millions in terms of damage to ships and maintenance. Alone. So it would provide power to a ship. It would provide power to a vehicle, motor vehicle, without transmission. But most importantly of all, I mean, my raison d'etre was that it should provide power to a ship in space. I mean, currently, the likes of NASA, they have, ion drive and plasma drives, but they require enormous amounts of fuel, and the power that they generate is equivalent, from what I've read, is equivalent to the waft of a budgie's wing, which is practically immeasurable. Now, what I have there is a very crude prototype machine that's demonstratively creating five pounds of thrust, which is probably several thousand times more powerful than what NASA are using now with ion and plasma drives. So,
yeah, thank you so much. Yeah.
I don't know. Does that answer your question, or?
Oh yes, yes, and I really hope you know, you will go your way, and then that will be all worked on by those with lots of money and resources, and then we will know more. But there is one more question that came to my mind: is that if you were to make it heavier or lighter, how will that change? You know, how it works. Say if you will make it heavier, double the weight, will it be harder to get it moving? Will it go faster, slower? What would happen?
No, it's if it was used in space, it would be irrelevant. It would only matter where gravity existed. I mean, if I made it lighter, it'll go a little bit faster than you've seen there. If I increased the motor power, it would go faster. If I made the drive itself bigger, it would go faster. But that again it's where I stop. I've had to stop now. I've spent years establishing the principle, and once I've established the principle, I believe I've gone as far as I can now. The principle is there. It's down to everybody else to develop it up off that. But certainly from a spaceship point of view, the weight of the engine is not relevant. The drive will be the drive. The engine weighs 1,000 tons and it's produced 1,000 tons of thrust. It really doesn't matter in space. But if you put the engine on a ship on Earth, then it may go a bit slower, obviously. But,
thank you. So it would be interesting to know what force drives it.
Well, that I would think will be told to somebody who's going to give me some books and some support. The force that drives it is within the unit, and that is the secret. I've demonstrated basically everything else to show that there's no sort of ulterior force and there's no ulterior motive, because I've seen lots and lots of those, and you've only got to look at YouTube and you'll see loads of them. And when you've worked on such a drive for so long as I have, you can look at those and you can say, I know what that's doing that. And it's not because it's creating linear thrust. It's because of, and you can explain it. But you've got to have really studied it and worked on those things for some years before you understand it's not true. And an awful lot of them, they're covered up. So you don't see the reality of it. You know, I've seen, I won't go into detail and I won't mention various drives and so on, but I've seen various drives that have been acclaimed on YouTube and various other parts, and I know that they don't work because I've done them 30 years ago. That's all part of my development and build up to what I've got now. You know, I've done a lot of these things years and years ago and discounted them because I am my own hardest critic. I will not stop until I have an explainable reason why something is happening. Because only when you get to that stage can you actually make it better. And with that unit, I believe I've reached that stage.
Yeah.
Well done. Thank you.
And Elżbieta, thank you, ma'am. Let me go to Morgan next. And again, we're running ahead of schedule. So I think what I'm going to do is go to Michael McDonnough probably at about 1 p.m. So that gives us about 20 minutes left for questions, if that works. So let me go to Morgan Lynch next, sir.
Okay, yeah, hi Tim. Thanks for the wonderful presentation, Mike. Just a quick question. I wanted to see if you ever just took the device, so you had it turned on where it scoots to the left. Can you ever just take the device and just hang it from a scale, or just put it on a scale and turn it on to see if you get weight reduction in that respect? Have you done this experiment?
I've done bits and pieces like that, but it's difficult to explain. If you hang it, you would have to hang it on quite a long thread, because what you will get, if you notice, the linear forces are being created by the rotational forces. And the rotational forces, once they go off vertical, will tend to push against each other. So you'll have to have a long thread. And yes, I've done that, and it'll move this and so on. One of the next things I was going to do was actually do it on a lift mechanism as well. But I really don't feel the need to do that, quite frankly, because there's reasons why that won't work, or it will work, or it won't work properly. So I can't say I have done that. No.
Oh, because yeah, no. Just my one concern is if it's like a friction type thing. Is this
No.
Similar? There's someone posted a link for the YouTube video of this lathe weight experiment. Is the actual mechanism on the inside similar to this, where you have a rapidly spinning disc on a barbell that's rotating around?
No, it's obviously I'm not going to answer questions regarding what's on the inside. But when you're saying a rotating disc spinning round, strangely you should say that. The first machine I ever made over 35 years ago was something like that. But the rotating disc I found was not necessary.
I see. Cool. Thank you.
Okay. And thank you, Morgan. Okay. So let me go to Detlef Hoyer next. Detlef, go for it, sir.
Hello, and thank you for the presentation. Just a short question. Are you able to reverse this thrust, perhaps by inverting the rotation? So it moves from left to right instead from right to left on the video.
And Mike, were you able to hear him okay?
No, I heard nothing.
Oh, okay. I'm sorry. Yeah, his voice was a little faint. He was wondering if you were able to reverse that so that it moves from, if you reverse the rotation, would it move from left to right instead of right to left?
No.
Okay.
No, for steerage, you can move the whole machine. It doesn't matter. No, reversing rotation won't make a difference.
Okay, wonderful. Let me go to Robert next. Sir?
Hi.
What about
Mike? Can you hear me?
Yeah, I can hear you.
I was just curious. Any other knowledge besides gyroscopes did you apply to develop this device?
Well, mainly rotational forces. But I mean, rotational forces are basically all encompassed in gyroscopic forces. But I can say it's using gyroscopic forces to actually convert from rotary to linear thrust. But gyroscopic forces are rotary forces. So to me, the two are one and the same.
But any other knowledge did you apply? Like,
well, there are other things contained within the unit that are responsible for the conversion. But at this stage, I really can't go into those without divulging too much.
Oh, okay.
It's, let's say, material science. Then. I'll just say that. There's a
I see. Thank you.
There's a degree of material science in it.
I see. Thank you.
Okay.
Well, and Robert, thank you as well. Okay, so let's go to, let me see. I think, Lulu, you had a, let me see. And if I, again, Lulu, if I could ask you to get your camera on.
Yes. Yes, hi. I had different questions. You know, you're saying linear force, and, you know, with linear force, it means it has to be exact, 1-to-1 ratios. I mean, you cannot achieve linear force unless it's 1-to-1 ratios.
I don't understand your question, Lulu.
Your equation to have lift force, you need variables, but linear force is 1-to-1 equation to be achieved.
Well, you've seen the video. You've seen linear force. It's totaling 5 pounds. That's all I can say. I do not understand your 1-to-1 equation. The linear force
1-to-1 equation of oscillation. 1-to-1. That's how you have perpetual lift. 1-to-1, 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 1-to-1.
Well, that's news to me.
That's you know.
I don't. As I say, I don't understand the question, quite frankly.
It's simplified.
Yeah.
Instead of these hard equations, it's just one equation.
Well, you can see the linear force. Oh, my internet connection doesn't say. You can see the linear force being created from the rotational force. The one-to-one equation, I don't know.
Yeah, Lulu, it could just be the way that you're expressing it. I
know what I'm talking about. But
no, I mean it's just not communicating. I think that might be just not communicating that well. But because I'm kind of the same way. I kind of feel where you're going with it, but I don't fully get it. Let me go back to
mathematics is a cryptograph of imaging. You can only achieve a visual unless you cover certain like thoughts, perspectives, like you go from something into something into something into something, and that changes just depending on the measurement. If it's not one-to-one oscillation for one to verify the other, then it does not.
You are obviously talking theoretical maths.
No, our visible universe.
Yeah.
Well,
Lulu, let me jump back to Detlef and.
You guys are watching, but you guys are not learning. You're not understanding or expressing whatever.
Detlef, let me jump back to you. And again, sorry, I'm bumping up our schedule a little bit, but so that I am trimming down our Q&A time a little bit.
I haven't been able to get in any signal.
I'm sorry?
It's Hugh here. I just wanted to see if I could ask a question later as well.
Yes. Let me have you go right after Detlef. Sir?
Okay, what I wanted to ask is if you put the machine on the magnetic levitating table, would it work also? With no friction? Yes, like the transrapid. When you have a magnetic levitating table,
yes,
there's no friction.
Well,
it's like in space.
Yeah, I believe it would. You've seen the machine demonstrated put onto a tray on the table, and it's driving that along. Equally, if I was to float that tray on water, it would drive it on water. I have driven it on water, actually.
On what?
On water.
On water.
It's on a flotation unit,
yes.
And it's moved. And it will move as I've not filmed that. But yes.
Yes, it would be very interesting if you will have a video of it on.
No, well, again.
On water. Oh, your picture is frozen.
Detlef,
well,
if I could jump.
The fact, well, I've just said to employ that friction. Even if it was friction, it is still moving in a designated direction. Random vibration or uncontrolled vibration does not move in a given direction. So even if there's an element
and we're losing.
And also, if you put it if on the tray that you've seen it on, the tray itself is being pushed along, and it's not friction. It's not holding on friction. The tray is moving with the unit driving it.
Okay. So let me. Thank you, Detlef. Let me jump to Hugh. Hugh, go for it, sir, and welcome back.
Okay, first of all, congratulations on a wonderful system. I've also used some inertial propulsion systems myself. And the problem I found was that they tended to go backwards a bit, sort of 2 steps forward for 1 step back, and they were sort of jittering. Another guy in this area is Stephen Hampton. You probably have seen him on inertialpropulsion.com. I find his ones are also a bit jerky. but yours was beautiful and smooth. So you must have overcome some of the problems in some of these other rotation to linear impulse systems where you're getting all this sort of jittering action. Yours was nice and smooth. I presume you have there's some trick there, but also I know why you're not you don't want to go vertical, because I appreciate that, because in some of my systems, I either had to build them for vertical or build them for horizontal, because they become too unstable if you tilt them upwards with the rotator. And I did actually get briefly some levitation with one of them, but it was so shaky, it was impossible. Maybe if you did a dedicated vertical one of your systems, you could get it to go more smoothly upwards. But it would have to be built, I think, to go upwards.
Well, yeah, I appreciate what you're saying. Unfortunately, I can't explain to you at this stage how it actually does it. I think the main thing is a friction, if you like, and they can only work when they don't know what is actually making it work. Now, I can demonstrate. If I was to open the unit up and say to you exactly how it is doing it, you will go, ah, yes, of course. And it is mechanical, it's purely engineering. There is nothing Foo Fighter technology in it. It's purely mechanical, purely engineered. It has to work, and you will see evidence inside of it actually working, actually converting. I mean, what it's doing essentially is converting rotational forces into linear force.
Right.
I can explain to a zenith exactly why it's doing it, and I can show you the inside and show you the reaction it's having inside and how it's happening, and you will fully understand. I can make it, I've made it jerky to take out a little bit of the weight and make it jump up a little bit so that the linear force being created is more demonstrable.
Yeah, I think I saw that in one of your videos. It was going a bit upwards.
Yeah. It jumps up a little bit, but that is only to sort of take a little bit of weight out of it so that the linear force that's being produced can be demonstrated. You can see the drive more effectively. I could adjust the machine so it doesn't jump up, but I wouldn't get anywhere near, because of the gravity inertia, I wouldn't get anywhere near the speed I'm getting along the ground to demonstrate the inertial propulsion. So I adjusted it to jump a little bit and demonstrate the inertial propulsion that's being created. Now I could open the machine up and show you exactly why that force is being created within the frame of reference.
Right. Yeah. I'm sure that you could, if you were given millions of pounds or dollars or euros, you could develop that into a vertical thruster.
I could develop it now as a vertical sculpture, but I'm 76 years old. It's not millions I need, it's years. If someone can pay me in some years, I'll carry on. But I'm 76 years old now, so I don't have the time anymore. And I've gone as far as I want to go. I believe the machine needs to be taken into the realm of the public now, and it needs to be developed as a machine, an all-purpose machine for whatever.
Thank you very much.
Yeah, okay.
Yes, absolutely. And thank Hugh as well. Okay, and let me see. Let me go back to Robert, sir.
Thanks, Tim. I have just one, I think it's a short question, Mike. Do you know anybody who has been closer to trying to repeat Lathwaite's so-called barbell machine that could just lift up with one hand? whereas if it was shut off, it would weigh a ton.
I don't, but I think I know why it doesn't weigh. I know why, because it's on a directional plane, and a directional plane is acting against gravity. So when it's holding the bar, the directional plane will not allow it to drop, because it's if you like, my problem is I can think three-dimensionally, but I can't talk three-dimensionally. I can understand why it happens, but I cannot explain it fully. I cannot explain it in a coherent manner. The barbell itself is spinning on the end, and it won't drop down because it's creating forces top and bottom of the rotation. It's stopping it falling. So while you've got hold of the bar, and you are holding that bar and allowing the gyro to precess, as soon as you stop the precessional force, that will drop. It will get its weight and it will drop. Right. You've got to keep moving it around in precessional force, and it will stay up. That is one of the sort of enigmas, and one of the things that fascinated me about gyroscopic and rotational forces.
Right. Me too. Yeah.
The anomalies created by them, and it's these anomalies that I've used in that unit. I will put it this way: I've used collectively in that unit there is rotational force, there is recoilless centrifugal force, there is rotational force, and there is precessional force.
Right.
And they're all acting well. I've gone a bit too far on that, but it's a combination, and if you like, amalgamation of rotational forces and gyroscopic force.
Sure. Yeah, that's why I specified gyroscopic, because that's all I can think of that lathe weight applied. Other than what you mentioned about material size, but the forces must, as you said, must have been vertical. I mean, that's obvious.
Well, yeah, the forces are acting against each other from the center downwards. You've got the top of the rotation is reacting, and the bottom of the reacting, and they're reacting in opposites to each other. So basically, they become practically weightless as long as they're precessional. Now, as soon as you stop the precession, the weight comes on, or you stop the spinning, the weight's there. There's nothing rotating and moving, if you like, moving the center of gravity or the mass, altering the mass. So the thing drops down.
I've made a simple model in SolidWorks, a 3D model. So if you're interested in looking at it, it's a simple diagram you can see in any gyroscopic book. But I'm sure you've seen it, of all the vector forces on a rotating flywheel.
Yeah. Well, guys, we're just about out of time. Bernie, I'm sorry, I had to put your hand down. In this case, we have to go back. Let me go back to gallery view, and everyone, please give Mike an enormous hand once again for a wonderful presentation. And we are, again, we're running a little bit ahead of schedule now. We were behind schedule before, we're ahead of schedule now. So what I'm going to do is, at the top of the hour, Michael McDonnough has joined us, actually. And so what I want to do is give him an introduction.